What's optimal for HDL? That's what we'll start to see here. This is a study of almost 16 million people. On the y-axis, we've got the hazard ratio or risk of death for all causes, and that's plotted against HDL on the x. And then we can see that lowest risk of death for all causes was associated with the 50 to 69 milligram per deciliter range. Now, when HDL was less than 50 and greater than 70, it was associated with a significantly increased risk in both men and women. So from this study of 16 million people, we can see that both low and high HDL are associated with an increased all-cause mortality risk. And this is part of the story for going into determining what's optimal. The other part of that story is that HDL declines during aging. And if you want to see those data, I have a new Patreon tier dedicated specifically to what's optimal for biomarkers. This tier currently includes data for HDL and is shown with the optimal range there, but also 36 other biomarkers, almost 2.5 hours of video content and counting. I'm going to keep growing this tier into as many biomarkers as possible. 62 published references, and note that these aren't the reference ranges which you can get from any LLM these days. This is how each of these biomarkers changes during aging and or associations with all-cause mortality risk in the largest studies that exist. So if you're interested in getting all of that data in video format in one place, check it out. All right, so what's my data? That's what we'll start to see here. This is HDL, as I have 73 blood tests for HDL going back to 2010. For the first 5 tests from 2010 to 2013, we can see that average HDL was relatively low at 36 milligrams per deciliter, and one of those tests was as low as 28 milligrams per deciliter. So then I had the idea of how can I increase HDL? I mean, at that time, there were virtually no studies on increasing HDL. So let's take a look at the approach for calculating correlations for diet and supplements, but also other factors like body weight, which will be important later in the video, with biomarkers. For those who are unfamiliar, all food has been weighed, or almost all food, almost 99% of all food has been weighed since 2015. Now in 2015, I started tracking macro and micronutrients, and it wasn't until 2018 when I had the idea to start tracking foods, as foods is the least reductionist approach relative to tracking macro and micronutrients. And all of that whole combination is important. I wouldn't say to track only foods or only macros and micros. I find the most value in tracking all of it together. I then enter those data into a diet tracking app, Chronometer, and I'm not here to say they're the best. That's what I've used since 2015. If you're using something else, that's great, but that's what I've used since 2015. I then take the Chronometer data in terms of macro and micronutrients, but also the food amounts. I then enter that into a spreadsheet. So now, because I've entered the diet data into a spreadsheet, each blood test has a corresponding average dietary intake. So if there are 50 days in between tests, I take the average diet over those 50 days, and then that lines up with the latter blood test. So now every blood test has an average dietary intake. And then after 3 tests, we can calculate correlations. Now, as a quick note, after 3 tests, there's going to be a lot of noise, but some signal. And it does take a few tests, or a lot of tests, sometimes up to 20 tests, to try to help the signal separate from the noise. But after 73 tests, the signal should be fully separated from the noise at this point and help defining what recipe may optimize HDL, at least in my case. Now note that we can use this approach even with 2 tests. If you have 30 days of track data before test number 1 and 30 days of track data before test number 2, you can do a 2-sample t-test and see what's different between those 2 dietary periods that correspond to those 2 tests. And then there may be 10 variables that change. You're not going to know which one, so you may have to try to change all of them. But at least that's a data-driven approach to try to have some insight into what may move your biomarkers in the right direction relative to wrong. All right, so back to our data. And now looking at all of it, the other 68 remaining tests since 2015. From 2015 to 2022, I had some success in following this approach with average HDL of 45 milligrams per deciliter, which is better than those first 5 tests of 36 milligrams per deciliter. But then starting in 2023, we can see that almost every test, except for one, was in that optimal or that Lustgarten optimal range of 50 to 69 milligrams per deciliter, with an average of 58 milligrams per deciliter during that time. One was a bit too high, 77. That's my highest HDL ever, even going back to before when I wasn't tracking diet. But these data show that HDL is not stuck in the mud or genetically determined. You can increase it from a low of 28, which I had, up to 77. So then the big question is how? Which factors are correlated with HDL in my data? And note that my data may not translate to others. I wouldn't say follow my diet or follow my approach for exercise or anything else. I would say track your own data and look at your own correlations. Or if you'd like for me to help, I do offer that as a consultation to see what may be your personalized recipe for optimizing as many biomarkers as possible as a strategy for slowing aging and disease risk and potentially extending and maximizing longevity. So which factors are correlated with HDL? Now, the biggest factor, at least in my data, is body weight, as 56% of the variability in HDL can be explained by body weight, which is what we'll see here. On the y-axis, we've got HDL, and on the x, we've got average daily body weight. And note that this is using the same approach as for calculating correlations for diet with biomarkers. So I weigh myself every morning after using the bathroom, and because I'm tracking body weight, for every blood test, I can take the average, test-to-test average. Again, if there are 50 days in between tests, I can take the 50-day average body weight, which then lines up to each blood test. So each data point that you see on this plot is the average body weight from the previous test until the next test. And then when looking at the correlation, we can see that it's a strong correlation, as anything less than negative 0.7 is considered strong, with a correlation coefficient of negative 0.75, and that p-value is far below that significance threshold of 0.05 at 2 times 10 to the negative 13th power. So these data suggest that when my body weight was at its highest, that's significantly correlated with my lowest HDL. And conversely, when my body weight has been at its lowest since 2015, that's been significantly correlated with my highest HDL. But what about diet? And can we do better than just 56% of the variability? Can we get closer to identifying what may be the recipe for optimizing HDL, at least in my case? Within that context, calorie intake is significantly correlated with HDL, and we're going to take a look at that in a minute. But I just want to mention that these are just two of the correlations for HDL that I'm looking at in this video. If you want to see the full list of all macros and micros in foods, that's on the biomarker or the correlations tier on Patreon. And that tier doesn't just include data correlations for diet versus HDL. It includes diet versus all of the biomarkers that I'm tracking, at least 40 biomarkers. And that doesn't even include metabolomics, as I post correlations for diet versus metabolites that are obtained by metabolomics, so 623 metabolites. So there's a ton of correlation data on the correlations tier on Patreon. If you're interested in that, check it out. But for now, let's take a look at that correlation for calorie intake with HDL, which is what we'll see here. On the y-axis, we've got HDL, and now on the x-axis, we're looking at the average daily calorie intake that corresponds to each blood test. Again, same approach. 50 days in between tests, or however many days in between tests, I take the average calorie intake, and then I line that up with the latter blood test. That's how I'm able to look at these data. In terms of the correlation, we can see that it's negative 0.44 and statistically significant at less than 0.05. So what these data suggest is that when my calorie intake has been at its highest, close to 2,800 calories since 2015 over that 11-year span, that was significantly correlated with my lowest HDL. And conversely, when calorie intake has been my lowest, around 2,100 calories per day, that's been significantly correlated with my highest HDL. The combination of these two variables, calorie intake and body weight, now explain 60%, not 56%, which was just body weight alone, of the variability in HDL. And that's what we'll see here. This is a multivariate linear regression model that has calories and body weight, and we're looking at their collective association with HDL. In terms of the p-value, we can see that individually in this model, they are statistically significantly associated with HDL. But more importantly, we want to know the model significance. In other words, is the combination of body weight and calorie intake significantly associated with HDL? And we can evaluate that by looking at the significance F, which is far below a statistical significance threshold of 0.05. And then in terms of the percent variability explained in HDL, we can see that with the adjusted R squared at 0.60 or 60%. Now, 60% isn't too bad from being able to predict a given biomarker, but can we do better? And we can. And that involves 4 variables now: calorie intake, body weight, saturated fatty acids, and ginger. And the combination of these 4 variables, when looking at their collective association with HDL, we can see that it's statistically significant. And now that significance F has an even lower p-value than the previous model that only included calories and body weight at 2 times 10 to the negative 17th power. And we can see that the adjusted R squared is now 0.81 or 81%. In other words, the combination of these 4 variables, calories, body weight, sat fat, and ginger, explain 81% of the variability in HDL. Okay, so these may just seem like numbers, so what? What can we do with these data? Well, we can use these data to predict HDL for the next blood test. And to do that, we're going to use the coefficients as shown there, the beta coefficient. So how do we do that? First, we start with the intercept, which is 165.9. We add that to the beta coefficient for calories times average daily calorie intake since the last test. And for those who haven't seen those data, which I post every day on Patreon, average daily calorie intake is 2,400. Even though the coefficient for calories says 0.00, it rounds to 0.00, but it's actually 0.005. So when we multiply the beta coefficient for calories by 2,400, that's one part of this equation. Using that same approach, for body weight, the beta coefficient times my average body weight since the last test, 144 pounds. Same story for sat fat. Average sat fat intake is about 19 grams per day. So when we multiply that by the beta coefficient for sat fat, which is 0.57, and then also ginger, we multiply the beta coefficient of 1.93 times my average ginger intake since the last test, average daily ginger intake since the last test, which is 7 grams per day. So then when we take the sum of all these data, I get a predicted HDL of 60 milligrams per deciliter for the next test. So is this accurate? Is this equation accurate, which can explain 81%, or so far can explain 81% of the variability in HDL? Well, the next test is scheduled for June 17th, 2026. And if you're watching this on Patreon, that's tomorrow. If you're watching this on YouTube, it's been a few weeks since I blood tested and blood test results are in. So if you want to see those data as soon as they're posted, check us out on Patreon. If you're interested in more about my attempts to slow aging, check us out on Patreon, where I offer blood test consults, but also post at least twice per day in 4 other Patreon tiers. We've also got a whole bunch of discount and affiliate links that you can use to test yourself that help support the channel, including ultralabtest.com, Life Extension, at-home metabolomics, NAD testing with Ginfinity, epigenetic testing with True Diagnostic, at-home blood testing with SciFox Health, oral microbiome composition, diet tracking with Chronometer, as I mentioned in the video, green tea, which I drink every day, clearly filtered water filter, which I'm still using every day too. Or if you'd like to support the channel, you can do that with the website, Buy Me a Coffee. We've also got new merch, including what you see here, the Health and Longevity Optimizer, and other merch, including Data is my North Star, as I've got on here, Figuring Stuff Out is my drug, and the ConquerAging or Die Trying logo. Link in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.